Hi, in this video we are going to look at solving two types of equations. So first rational fraction ones, and then secondly radical equations. Okay, so the first type of question, and you can do these in multiple ways, but from my experience by far the easiest way to solve an equation in which there are fractions, denominators, is to use what I like to call the I hate fractions principle. I think the book might say clear fractions principle, but I hate fractions sounds better. And what it says is basically is you can multiply every term of the equation by the same thing, and that's the principle, and it doesn't change the equality of the thing. For example, if I have x plus 2 equals 4, so I could take, I wouldn't, but I could take and times this by 3, and this by 3, and this by 3, and I'd get 3x plus 6 is equal to 12. And if I solve this equation, or if I solve that original equation, x plus 2 is equal to 4, I'm going to come up with the same answer. 4 take away 2 is 2 in that case. In this case, I'll subtract 6 from both sides and get a 6. Divide, I come up with the same answer. So the idea is multiply every term by the same thing. And then the main thing is what you want to do is pick the right thing to multiply it by. And the thing that gets rid of the fraction is if you multiply everything by a lowest common denominator. So if I look at 3, 2, and 1, the lowest common denominator would be 6. So I'm going to take the first term and times it by 6, the next term by 6, and the last term by 6. So in this first term, 3 goes into 6 twice, and so I'll be left with 2 times t plus 1. Notice no fractions. So I'm not getting a common denominator and keeping it. I'm just finding the common denominator, then multiplying every term by it so I can get rid of the fractions. In the next one, similarly, 2 divides into 6 3 times, so I'll have minus 3 times t minus 1 is equal to 6 times 1, or 6 times 1 over 1, whichever, comes out to 6. Now notice that I put this step in there, right here. Some people would just say, oh, it goes into 3, and then they'd start multiplying by what's in brackets after. I like to put this step in because it reminds me that that's a dirty, rotten, filthy, stinking negative, and I have to apply it to both terms in the second bracket. Okay, so now to solve, multiply 2t plus 2 minus 3t plus 3, that's where a lot of people make mistakes, is equal to 6. 2t minus 3t is a negative t, and then I'll have 6, and then minus 2 minus 3, or minus 5 on this side. So I'll have minus t is equal to 1. Divide both sides by t, or by negative 1, and I'll come up with t is equal to negative 1. Okay, so that's sort of the I hate fractions principle. Let's try it with a hard question. Okay, so here we go. Now, if I have polynomials in the denominator, in order to find that lowest common denominator, I first need to factor each of those, if I can. So the first one, x plus 2, you can't factor, so I'll just leave it. The next one can't factor, but this one on this side, I can take an x out of that, so it's x, and then x plus 2. So now in finding my lowest common denominator, so here's a term, and then this one's got 2 terms. So my lowest common denominator has to include each of those factors. So the LCD for this one is going to be, you need an x by itself, and you need an x plus 2. And now, so this is representative of all of those denominators. So, and this step will look messy, I'll have 3x over x plus 2, and I'll have 6 over x. Notice I left a little space there. And I have 12 over x times x plus 2. Now, factor first, look for lowest common denominator, and then multiply every term by that lowest common denominator. So I'm going to multiply this by x and x plus 2. I'll multiply this by x and x plus 2. And I'll multiply this by x and x plus 2. Okay, so now we get to hack and slash. So here's an x plus 2 here, and here, gone. So in the first term, I just have x times 3x. Okay, plus this one, the x's cancel out. Whoops, x's cancel out. So I'm left with 6 times x plus 2. I rearrange those just because the numbers with your multiplying usually get written first. Is equal to, on the other side, the whole thing cancels out. So I just have 12. So now notice I had fractions. I used the I hate fraction principle. Here, no fractions. And now I just solve that equation. So to solve, this would be 3x squared plus 6x plus 12 is equal to 12. It's quadratic, so I'll bring this 12 over to this side and subtract. Oh, that's going to go away. So 3x squared plus 6x equals 0. And now I can factor that. So a common factor would be a 3x. And I'd be left with x plus 2 is equal to 0. Zero property says that either 3x is 0 or x plus 2 is 0. So this one, when I divide by 3, it comes up with 0. This one comes out to negative 2. And at this point, I'm feeling awfully good because my answer's x is 0, minus 2. I've done everything good. This is good. But always you want to check your answer. And like I say up top here, if we can read that, whoops. I'm moving things around. It says, check your answer. Look for getting a 0 in the denominator. So let me look at the top, that part there. If my answers were, sorry, this is sort of scrolling funny. So if my answers were 0 and negative 2. If I put a 0 in right here, I have 0 in the bottom of a fraction. Bzz, can't do that. And so 0 I have to cancel out. So I can't use that. And then negative 2, if I put that in right here, negative 2 plus 2, that also gives me a 0. Bzz, can't do that. And so that can't be an answer either. Therefore, I would say no solution. So you may do some really cool looking math down here, and you might be feeling good with it, but you always want to check your answer. And in this case, there'd be no solution. So that is solving rational equations. Here's a radical equation. These ones are fairly straightforward. The only trick is you have to make sure that you isolate the radical. So this piece here, I want to get on a side of the equal sign by itself. So I must lose this minus 3 first. So I'm going to add 3 to this side. If I do that, I have to add 3 to this side. So I have the square root of m minus 1 is equal to 8. And now I use the square principle. And often when we do trig equations, I might have something like 2 sine theta minus 1 equals 0. Same thing, I need to isolate this piece. So I'd add 1 to both sides, and then divide both sides by 2. And then I'd apply some kind of sign principle. But it's the same idea. I need to isolate something and then apply a principle. So here I isolated the square root, and now I apply the square principle, which to get rid of the square root, I can square this side, and that'll cancel, leaving me with just an m minus 1. But if I square that side, I got to square this side too. 8 squared, 64. Add 1 to both sides. My answer comes out to 65. Again, like the rational equations, you want to check that. So going back to the original equation, square root, it'll be 65 minus 1 minus 3. Is that equal to 5? 65 minus 1 is 64. 60 square root of 64 is 8. 8 take away 3. Sure enough, it's 5. Therefore, m must be 65. Hopefully that helps you with the rational and radical equations.